request is means inside the GitHub, you have
Hmm.
to add merge the new code sent by the team members, right? In the master
Yes,
branch
yes.
code.
Yes, yes. It's happening merges. Basically, pull request is nothing but a merge request. Simple.
Mhm.
Merge request. Review request. Earlier we used to do manual review, but now it's been automated. Got
Rajesh,
it,
one
all of you?
question.
Hmm.
Once the pull request has been done, like the approver approves it, and what
Hmm.
if like there is a change, and once that is approved, like do we have to go through this process again and again to keep track of changes, or can that be like simply undone? Like
No,
for
no, no.
example, F fee one was created, 111 was created,
So
so.
what happened? You modify this code here. So you want to correct the previous mistake. Same thing. Modify the code, add commit, push, and pull request. This is the history. Remember, whether it's bad history or good history, it is a history and it is a version. Git will store that. But same thing you have to repeat.
Okay, the reason I asked is like, okay, what if the reviewer is like tied up with like other things and he cannot approve your request like over the next 10 minutes or so, then how will those changes be stalled in real
Uh,
time?
n- Nothing can be done here. See, remember that. Why we have approver in place? Because without his approval, there should not be going any code to the production. So if he is not available, it's a project problem, right? Getting
Okay.
points. So management has to fix this. So, okay, so there's one approval which is not available. Maybe he's on leave. So we should assign to someone else who's responsible for it. So this is the process problem actually.
Okay. So like in terms of like when a release is happening, let's say there is a major release and there are all respective individuals who are tracking and all of this. So will this be like a continuous process like where changes
Yeah,
are
yeah.
done and somebody is like on top of it?
Yeah, yeah, this will be a continuous process.
Okay.
Without see earlier, what was happening? We have a 20 developers in a team. Everyone will do the push based on their will, without understanding that it will break others' code or not. So reviewer is important actually because without having the features in production and having the wrong features in production, there's a two different things. Remember that. So let's say
Yes, yeah.
if you're okay if you don't have one more extra feature on Paytm, but the fundamental feature you should not break. Okay, so remember that.
Okay.
Okay, so now this is one thing, but guys, there is one more aspects of pull request. So here I
Sure,
talked about
sorry,
there's a
Rajesh, one question. So once
hmm.
the merge is done, in any way we cannot revert it back, right?
Yeah, so you have to revert. See, understand that.
Suppose, yeah, it is requested, it is approved and merged to the main branch, the master branch. But
Hmm.
still, we found that no, the previous code was better, and this is causing some
Yeah, so
issues. So, how?
you can do that. So you can do that very well. So for example, if you see that I'm teaching you the revert process in the local, ultimately how do you modify this code? Whether you correct or revert is up to you. Let's say this is the bad code, okay, and this is a good code. So can you know to revert it? So git revert. It's not reverting like you lose the history. It will be there. So I'm just reverting this code, paste it. Revert, this is the command, revert command. They'll ask you why you are reverting. I gave this region, and the revert has happened. And after that, I'll push it. Wait a second. I'm pushing it. And after that, I'll create a merge request. Let me show you here. So remember that whatever the commit I made it here, somewhere here, I reverted. So reverted also, bad code also is a part of a Git. And then on top of that, you are reverting. Getting once.
Yeah, so reverting we are doing in my local repository, then
And
and
then
pushing
pushing it.
that the trace code
Pushing.
to the to
Yeah.
the
Yeah.
remote repository. Then again
See,
it will merge. Yeah.
this commit which has a that fee 1111 is not there. But if you go to the older commit, which is last one, which is here, and if you see that, how can you see browse files? Yeah. So here you see 111 is there. So yeah, it's up to you. Good.
Here I just got it.
Yeah. So yeah. So coming back to the something else I was talking about. So here, what I did, you had only one repo, two branches. But you know what happened? Sometimes you don't have the access to entire repository. Yes, you don't have access to entire repository. So what you will do? How can you send your code to that repository when you don't have access? You can't keep it blaming saying that. So there is a Git has introduced one feature called forking. So look at this here, forking. I cannot fork my own repository. Okay, so that is a problem. I can copy it, but I cannot fork actually my own repository. Okay, so you can create a fork. So fork means what will happen? You know, when you fork someone else's repository, then this repository will be created one clone on the GitHub itself, not locally on GitHub. Forking means creating a clone of the repository, but at a GitHub only. Okay. Now, the beaut idea is this is owned by your organization. Okay. And the repository which you forked it out is owned by you. You are the owner of it. Let me fork someone else's repository to make a sense of it. So go to the GitHub. And there's some people. Hey, some people, where are you? Some code, Java code. I'm searching some code, okay? On the GitHub overall. There's so many repositories. This is not owned by me, you see here. This is owned by PubNub. I don't know what exactly. And so many people have forked it out. What is exactly that is? Okay, it's for the Java, Android, API-based applications. So I'm forking it out. And I'm forking out where? Not here. I want to fork it out to demo temporary. And this name is already there in my owned by me. So create a fork. So now you see that this is the repository who's owning DevOpsSchool-demo. That's me. And from where? Here. Okay, and now you will modify this code. I don't want to do something stupid. What should I do? I'm thinking. Just modify this code, whatever it is, and just adding some stupid content, just for faking out. And I committed this. Remember, I committed my own repository through UI. You could have done it through the laptop also. Add commit process and all. UI also you can use it. And after that, you know what we'll do? See, this is the primary repository. This is my extra code I have committed here. I'll go to this and new pull request. And now between the repo to repo, look at this here. This is my repo. This is the parent repo. How many changes you have? One changes, which is here. I'm not going to click pull request because he will abuse me for sending this request and waste of time for him. But it can be done like this also. Did you understand that?
Yeah,
All of
Rajesh.
you?
So any public repository access is there, so we can make it fork, right, to our repository.
Any other repository, you can fork it out. Simple concept.
Yeah.
And you will become owner of it if you have access.
Okay.
So this is something which we have in the forking. So yeah. Now last feature what we have is CI feature. So for CI purpose, for CI functionality, I'll be teaching you Jenkins, which is almost end of the sessions. But for this also you have a features here. Let me show you. So go to in this repository, and there's one feature we call it in GitHub we call it actions. So remember that I've been telling you since first day. You are going to write a code. You are going to write a code for product. You are going to write a code for product in Python. You are going to write a code for the testing the product in Selenium or JMeter or JUnit. You are going to write a code for infrastructure in Ansible, Terraform, and all. You are going to write a code for CI using Jenkins. So here, action is nothing but you are writing a code for CI. Again, you're writing a code for CI. So action is equal to CI, and action is equal to coding. So you will write a code here. So these are the template has been given, suggested template. What kind of code you have? Java with AND, Java with Gradle. If you don't know this technology, Maven and all Gradle, which I'll teach you, you will get to know slowly. Okay, so you can write a code here. These are the template has been given. So you want to introduce some coding practices, CI coding in this repository. So let me go. I'm just looking for it where exactly that option is available. And here, okay, it's here. So UIs keep changing actually, so don't worry about that. So these are the templates they have given it you, but I'm not looking for the template. Set up workflow yourself. And here, this is the file. Look at the directory here. The code will be in YAML inside the workflows.github directory. And this is the code you will write it. Okay. So here you will write a code main.yaml the content. I can show you some simple code, but right now committing this empty file actually. So this is the code. Now the idea behind this action code I have written is empty file, and you see here the moment this code has changes, the moment you have a code changes, this will automatically will run. So this has run and failed actually. Why? Because there's nothing actually. But I want to show you this the one run. I want to show you the failure, but I want to show you the code. It will run on the code actually. So here I'm modifying the code. Let's say other.txt, edit some code I'm writing, committing, and you see come to the actions, and you see second. So how beautifully this is planned, you modify the code here, automatically build will happen here with actions and give you the feedback, and super, right? Are you understanding this part?
It is.
So now the question is, how do we write that file? So I'll show you some examples for this file. So let me go to my simple repository. That's where the code is lying. So go to demo lab, view organizations. This is the sample repository for the demo. All the time I use it. This is the Maven code you have here, and this some source code, sample source code you have here. So, and here you have actions. You see that this is the actions code, and main.yaml. See, this is the code actually. So right now I don't want you to get lost in it. Just be comfortable with it. Someone will ask you, hey, what is action? So it's a coding for CI. What is in format? YAML file. Where is located? Inside this location. How do we write it? Slowly you will get into that. So I'll explain it to you this code also in some time. But I want to show you this is the working code. And what I will do, look at this my screen. I will modify this code. So this is my favorite file. Where is that? readme.txt. This I'm modifying some code here. It can be done through the push also, and commit the changes. Now the moment I committed, you see that build is started happening. Look at, refresh this. See here, 25th workflow. This is in progress right now. Queued. Okay. So now this code will be done, and you will see the reports based on the main.yaml content. What will be done? It's taking time. I don't have patience actually. Okay, so now the question is, you must be thinking, where is being done actually, where the build is happening. So build is happening on the infrastructure provided by GitHub. Okay, so see that build is pass. Okay, so now I want to see that what is the build all about it. So main.yaml, look at this, what you are writing. So you are saying, hey, whenever someone pushes the code and pull request made it, doing the build, or do start the trigger this build. That means this is the trigger mechanism. But what you will do, so here start this job. What job? Build job. Where it should run? This will be running the container. The name of the container is Ubuntu. Who is managing this container? Container is managed by GitHub. Okay. And now what you should be doing. So check out the code in this container. And this, you know that, correct? Do let me know.
Yeah.
Simple Linux code. This is also simple Linux code. This is also simple Linux code, but here is something else. And here you are doing some packages. Here you are doing some image creations and all, image building and all. So like this, you will write a code. Okay, right now, see here this packaging is command is running, ambient package. When I have a session on Maven, you will see that, understand this line. Okay, so yeah, this is the file which you write. Here you have one job and two job you have actually. So build and push image, two jobs. Where it will run? Inside this. On what it will run? Here it is. And simple. So like this, you'll understand this code also. The idea behind this is called action. Action is equal to the coding for CI and so on. So guys, are you understanding, all of you? All of you?
Here I just.
Yeah. So now guys, if you want to do the scanning of the source code to find out the security issues, this will be used. So just know about it. Right now you don't have to use it because you are using SonarQube for it. And so on. So guys, this is a Git and with a GitHub. Now maybe you are using Bitbucket or GitLab. So almost the feature wise, it will be same feature. UI will change. All the commands which I taught you and the flow which I taught you in today's session, 100% it will work on the different platform like GitHub, Bitbucket, GitLab, Gerrit, AWS, Azure, or something like that. Only URL will change. That's all. And UI little.
Thanks for watching. Want to study further? Join our training programs today.